Now in question number 1, as you can see, they have given you a displacement time graph. Now first of all, you must remember that from the displacement time graph, you can calculate velocity by calculating the slope of the sketch. Remember this. You can calculate velocity by getting the slope of the sketch. Now see, in the first part they have asked you to calculate velocity between 0 to 2 seconds. Now in the graph, if you see, then you will be finding that the sketch between 0 to 2 seconds. So you can see in this sketch from 0 to 2 seconds. In between 0 to 2 seconds, you are getting this sketch. So what you need to do, you need to find velocity of the slope of this sketch. Slope of this sketch will give you velocity in the time interval 0 to 2 seconds. Okay, so let's get the first part. We are needing to calculate the velocity in first part. So velocity will be equal to slope of AB. Now how do we get the slope? Formula is y2 minus y1 upon x2 minus x1. Now for this, you will consider 2 points on this sketch. As the sketch is moving in the downward direction, so A is the first point. So whatever we get value for x and y at this point A, that will be your x1 and y1. Okay, so at point A, you can see from the sketch x1 is 0 and y1 is 25. Okay, the second point is B. So now you can see that at this point B, value of x will be 2. So x2 is 2 and value of y will be 10. So y2 is equal to 10. Now let us substitute these values over here. y2 minus y1, so it's 10 minus 25 upon x2 minus x1, so it's 2 minus 0. So you will be getting minus 15 upon 2, that is minus 7.5. So this will be the velocity in between time interval 0 to 2 seconds. Now here you can see velocity with negative sign indicates that body is returning back towards the initial point. The second part, you have to calculate velocity between 8 to 12. Okay. Now let's see in between 8 to 12. So you can see here in between 8 to 12. You are getting this portion of the sketch. So let's name this portion as CD. So to get the velocity here, you need to calculate the slope. So again we can write velocity in the second part will be equal to slope of CD. Formula will remain the same. Formula was y2 minus y1 upon x2 minus x1. Now let us consider these points C and D. As you can see, graph is moving in the upward direction, so C will be the first point. So let's see what are the values at C, x1 and y1. So moving towards the x-axis, it's 8, and moving towards the y-axis, it is 20. Similarly for point D, moving towards the x-axis, you are getting 12, and moving towards the y-axis, you are getting 25. Substituting these values, so it's y2 minus y1, 25 minus 20 upon x2 minus x1, it's 12 minus 8, so that's 5 upon 4, so you can get it 1.25 meter per second. Now here we are getting the velocity positive, so that means body is moving away from the initial. Okay, the next we have, you have to calculate average velocity between 5 to 12. Now if you have to calculate average velocity between 5 to 12, that means you first of all you need to calculate distance traveled between 5 to 12. So let's see how much is the distance between 5 to 12. So when body was at, body was at 5, when time is 5, then you can see displacement is 10. So at 5 seconds, displacement from the sketch, see, when time is 5, you can see displacement is 10. Okay, now we need from 5 to 12. So when time is 12, you can see here, then the displacement is 25. So at 12, displacement is 25. Now we need to calculate the average velocity in between this interval. So between this interval, that is from 5 to 12, displacement was from 10 to 25. So you can say total displacement in this interval 10 to 25, so you can say the total displacement is of 15 meter. Okay, how much is the time interval? So time interval from 5 to 12 is 7. So knowing the time interval and the total displacement, so we can get the average velocity. It's the total displacement upon time. So total displacement in the interval from 5 to 12, total displacement is 15 and the time interval is of 7. So this will be the average velocity, 15 by 7 meter per second. This is clear to you? Now see, in question number 2, they are saying a train starting from rest picks up a speed of 20 meter per second in 200 seconds. So that means in 200 seconds, the speed of the train goes from 0, body was at rest, from 0 to 20. So initially there is an accelerated motion, right? Body is starting from rest and reaching to a speed of 20 meter per second. So speed is increasing, so that means there is an acceleration in the first 200 seconds. It continues to move at the same rate for next 500 seconds. That means for next 500 seconds there is uniform motion. See, first there is an accelerated motion for 200 seconds and then it continues to move at the same speed. Then there is a uniform motion and finally it is brought to rest in another 100 seconds. So here if you go through this portion of the question, you will find that there are 3 types of motion. In the first 200 seconds there is an accelerated motion. Then for the next 500 seconds there is uniform motion. That means neither there is an increase nor decrease in the speed. And then there is a retarded motion. So the first part says you have to draw the speed time graph. So let us draw the speed time graph. See? So we will draw a speed time graph. So this is your time axis, which is in seconds. Now first of all we have an accelerated motion for 200 seconds. Okay. Then after that we have uniform motion for the next 500 seconds. So after 2 we have to go along the time axis for another 500 seconds, so it will be 700 over here. And after that there is an retarded motion for the next 100 seconds. So 100 seconds more, so it will be 800. Now body starts from rest, and in 200 seconds it reaches to a velocity of 20. See, it's starting from rest, it's an accelerated motion, so it will go this way, and by the end of 200 seconds it will finally reach. See, by the end of 200 seconds, like this, the velocity will be 20. So your sketch for this will be this way. This will be the sketch. This sketch is showing that speed is increasing from 0 to 20 in 200 seconds. After this they are saying there is a uniform motion for the next 500 seconds. So for the next 500 seconds, that is by the end of 700 seconds, speed remains unchanged. It's a uniform motion like this. So first it's like this, then it's like this, and then for the next 100 seconds it is a retarded motion. So graph comes like this. So see, we have three types of motion. In the first type, it's an accelerated motion, AB. Then you have uniform motion, and finally it's a retarded motion. So graph will be like this. Now the question says that from the graph you have to calculate uniform acceleration. Now when we have to calculate the acceleration, you can see in this sketch AB portion is showing acceleration. So if you have to get acceleration, so you can see acceleration is shown by AB, so you can get slope of AB. Now this is speed axis, it's in meter per second. So slope of AB, so we will consider 2 points. Now if you consider the first point A, it's on origin, so you can say at A, x1 and y1 both will be 0. At the second point B, value of x2 will be 200 and value of y2 will be 20. So you can get the acceleration by getting the slope. Formula for slope is, okay, let's substitute the values here. y2 minus y1, so 20 minus 0, x2 minus x1, 200 minus 0. So it's 20 upon 200, it's 1 upon 10, that is 0.1 meter per second square. That's the answer for the first part, where you were asked to calculate the acceleration. Okay. Second part, you have to calculate uniform rate of retardation. So here you can see retardation is in the part CD. Now to get the retardation, what you will do, you will get slope of the part CD. As you can see, CD part is showing retardation. So we are going to get retardation. How? By calculating the slope. Again, we will use the same formula for acceleration. Slope of so slope of CD. Now when we have to get the slope of CD, you can see C is the first point, D is the second point. So at C, let's get x1 and y1. So x1 is 700 and y1 is 20. At point D, you can see x is 800 and y is 0. So x2 is 800 and y2 is 0. Now let's substitute these values in the slope formula. So y2 minus y1, so it's 0 minus 20 upon x2 minus x1, 800 minus 100. So that will give you minus 20 upon 100. This is 700 upon 100. So that will give you minus 0.2 meter per second square. So this we have got acceleration negative, so we can call it as retardation. Now moving on to the next part, they say you have to calculate the total distance covered before stopping, the total distance. Now how to get distance from the speed time graph? So if you have to get the distance from the speed time graph, you need to calculate the area. Now we have to get the total distance, so that means we need to calculate this total area. So you can see the figure formed over here is ABCD, and you can see that this figure is representing a trapezium. So to get the total displacement, so total distance, that will be equal to area of the figure ABCD. Now you can see in the figure ABCD is a trapezium. So we will be using the formula of the sum of parallel sides. So the parallel sides are these two sides, AD and BC. AD plus BC into height. Now height is this vertical line, you can say. So you can name it as BE. So this is the height, that is the perpendicular distance between the two parallel sides. So BE. So you can solve it now. As you can see from the graph, AB, this total length is 800, plus BC, from B to C, that means from 200 to 700. So from 200 to 700 it makes 500, into BE. BE is this vertical distance, and you can see this vertical one is 20. So this will give you 1300, and this will give you 10, so 13,000 meter. So you can write it as 13 kilometer. So the total distance traveled is 13 kilometer. Okay, the last thing we have to find the average speed. Now for average speed, we have total distance upon total time. So here you can see total distance in meter is 13,000 meter, and the total time is from 0 to 800, that is 800. So when you reduce it, you are getting it 65 by 4 meter per second. So this will be the average velocity.